Thank you all for joining us this afternoon to review the requirements of the two safety orders on ammonia refrigeration systems that we're going to be issuing this month. My name is Hamid Azarnoush. I'm a senior safety officer with Technical Safety BC in boilers, pressure vessels, and refrigeration technology. We're going to be starting with who Technical Safety BC is, and then we're going to be covering some like recommendations and feedback or on Fernie Memorial Incident and what happened at Fernie, as it has ties in hand with the safety orders being issued. Then we're going to go into the details of the two safety orders, following with the administrative requirements that you need to follow in order to become compliant with the safety orders. And at the end, we're going to be trying to answer all your questions. As Harpreet mentioned, please type in your questions within the chat box. We're going to be monitoring those questions and at the very end, trying to answer them one by one. Keep an eye for those questions because your answer might be actually coming on the following slides, but if not, we will get to all of those questions at the very end. Hopefully we have time to go over all of them. And if not, we're going to be providing you with an email address to reach out to us and answer your questions directly. So who is Technical Safety BC? As many of you already know, Technical Safety BC is formerly known as BC Safety Authority. We are an independent, self-funded organization, and we oversee the safe installation and operation of technical systems and equipment across BC. And other than issuing permits, licenses, certifications, we also work with the industry to mitigate the technical risks. Our vision is safe technical systems everywhere. And we do cover, other than like boilers and pressure vessels, we do cover a variety of technologies. Electrical, boilers, pressure vessels, and refrigeration, gas, elevating devices, railways, passenger roadways, and amusement devices. So what we do, we issue licenses to contractors. We certify individuals who are performing regulated work. We do issue installation and operating permits for regulated items. We approve product design when the design registration is required. If an incident happens, we investigate those incidents, and we enforce industry compliance. From time to time, we perform audits on sites or regulated works. And also we inspect the regulated item and regulated works based on risk. On top of that, we also provide education similar to what we're doing right now. So other than Technical Safety BC, there are some other jurisdictions who are covering regulated items here. BPVR, or boilers, pressure vessels, and refrigeration, is solely covered by Technical Safety BC. But when it comes to electrical and gas, there are some other municipality jurisdictions that have those technologies covered. Further information can be found on our website. You can actually get to our website, go to About Us and Our Story, and then there is a link for jurisdictional information, which you can get all of these information on that one. For gas, for electrical technology, basically Richmond and Coolant is also covered by Technical Safety BC. Other jurisdictions are taken care of by the local municipalities. And for gas technology, Surrey, Victoria, West Vancouver is also covered by Technical Safety BC. Other jurisdictions are basically depending on their capacity. But like I said, there are more information found on our website. So ammonia refrigeration risks and Fernie Memorial incidents. Since 2008, we've been seeing an upward trend on incidents reported to Technical Safety BC on ammonia refrigeration systems. The good news is that trend did peak around 2018. That is thankfully to the industry awareness following the incident at Fernie. However, and we're actually seeing a decline on that trend. However, the number of reported incidents are still significant and noticeable. So the risk still exists out there. During these reported incidents, we did actually see 41 injuries reported, 3 fatalities, which did happen at Fernie. 1 state of emergency was issued, and a couple of area evacuations were ordered as well. And what we found in common between most of these incidents that were reported is that almost 75% of them are caused by either equipment failure or inadequate procedures on operation and maintenance of the equipment. So as many of you may recall, back in October of 2017, province of BC did go through a fatal incident at Fernie Memorial Arena, which at the time did have an ammonia refrigeration system for their ice facility. That incident unfortunately did take lives of 3 individuals. It's resulted in issuance of a local state of emergency, as well as 95 residents of 55 homes were ordered to evacuate their homes for 5 days before they can safely return back to their homes. Following the incident, many regulatory organizations, including Technical Safety BC, started an investigation to find out what contributing factors did in fact lead into this fatal incidents. So today I'm not going to go through the details of the findings. We did publish a complete report, and it's available on our website. You can actually go through those that report, and there are so many lessons learned through that report that will help you move towards safety. But I'm just going to be touching on a few contributing factors here. One thing that were found was that there were competing priorities within the organization over allocating time and budgets for the maintenance of the aging equipment. We also realized that there were not really clear roles and responsibilities defined for those individuals involved with the safe operation of the equipment, especially when it comes to the decision making. Also, there were not a really sound understanding of the risks and hazards on ammonia refrigeration systems. We also noticed that there have been quite a number of employee turnovers through the history of this equipment, which resulted in a disruption of transfer of the knowledge between the outgoing employee and the incoming employees and future employees. Also, another thing that we noticed is that there were not any structured and organized maintenance program in order to perform regular and frequent maintenance on the equipment, as well as not really organized documentation method to keep the history of maintenance and repairs that were done on the equipment that would have actually helped evaluating the safe operation status of the equipment. So like I said, without going into the details, I'm just going to be talking about a couple of things that were found and the scenario that happened over at Fernie, because they are closely related to the safety orders that are being issued. So the first thing that I'm going to go through is the failure that happened on the secondary coolant system. Fernie Memorial Arena at the time of incident did have an ammonia to brine shell and tube type chiller for their curling rink, and that is to cool down brine in order to make ice on their sheets. This chiller at the time of incident was really old and has gone through extensive amount of corrosion, resulting in a pinhole created in one of the tubes that was separating brine from ammonia. As a result of that pinhole, ammonia started leaking into the brine. And because of that leakage, earlier in the day of incident, ammonia level within the room raised to a level that's triggered the alarm. And following that alarm, a decision was made to isolate this chiller, both on the ammonia side and also on the brine side. On the ammonia side, the chiller was isolated from the compressors and the rest of ammonia system, with liquid ammonia still left within the chiller. And on the brine side, it was isolated by means of isolation valves from the mains and slab piping, as well as from the two expansion tank that you can see in yellow in this photo here. On the ammonia side, because the ammonia was actually still kept within the chiller, and also it was isolated from the compressors, as heat was being absorbed by the chiller through the ambient within the room, ammonia actually started evaporating within the chiller, causing a rise in the pressure on the ammonia side. And this rise in pressure actually pushed more ammonia through that pinhole into the now isolated portion of the brine. So brine is a water-based solution, and it does have some capacity to absorb ammonia. However, because it was isolated and had only limited volume available to the continuing leak of ammonia, at some point it basically became saturated, and from that point on, it started building up pressure within the isolated portion of brine piping system. Unfortunately, the brine piping was not designed to withstand that kind of pressure, and it was not also restrained in order to hold any kind of loads due to either pressure or mechanical forces. As you can see in the bottom right corner photo, at some points, a sleeve coupling did break apart, causing a splash of ammonia-rich brine into the room, and that resulted in the ammonia level in the room rising to an estimated 20,000 ppm level. And unfortunately, at that same time, there were these three individuals still standing within the room by a compressor, talking about the fix that needed to happen on that compressor, and got exposed to this high concentration of ammonia and almost immediately lost their lives. Then following that incident, a decision was made to open up the emergency discharge line valve, or otherwise known as fire valve, in order to discharge the ammonia within the system into the atmosphere. As you may recall, I did mention that this failed chiller was already isolated from the remainder of ammonia system. So opening this valve up did not even mitigate the risk, as it did not evacuate the ammonia from the failed chiller at all. During the investigation, we also found out that the remainder of the system on the ammonia side was pretty much intact from the pressure boundaries point of view. And the system would have been much safer, and the situation would have been actually much safer with the valve being shut rather than opening it. But the decision was made, and then it did get open, resulting in about 650 pounds of ammonia getting dispersed into the neighborhood, and resulting in contamination of the neighborhoods, and an evacuation order was ordered to for the neighborhood to leave their homes for 5 days. Also, what did also add to complication was that this incident did happen in October, which is cold season at Fernie, and the cold temperature did also complicate the discharge rate of this ammonia into the atmosphere, and it took several hours, close to about half a day, before that 650 pounds of ammonia did get, in fact, released into the atmosphere. So one thing that did not happen was a cost versus benefit analysis to open the valve did not happen at the time. And perhaps during that emergency situation, there were not even enough time to perform a thorough cost versus benefit analysis right on the spot. So as I mentioned, following the completion of that incident investigation, an incident investigation report was put together. And through that incident investigation report, there are 18 recommendations put forward to different sectors of refrigeration industry. There are recommendations to owners, operators, maintenance managers, training providers, contractors, as well as a few recommendations to Canadian Standard Associations or CSA Code Committee. The first recommendation to CSA Code Committee was recommendation number 1, which was asking Code Committee to include design, configuration, and condition requirements into CSA B52 to ensure the secondary coolant portion of a system can safely withstand the effects of a refrigerant leak. Basically, the very thing that happened at Fernie. This recommendation, however, made it to the Code Committee and did not leave them enough time in order to implement it into the upcoming revision of CSA B52. Incident did happen in 2017, in October of 2017, and the new revision of CSA B52 was in line to get published by end of 2018. And by the time that the incident investigation was wrapped up and the recommendations was put forward, it did not leave them with the Code Committee for enough time to thoroughly implement those recommendations within the body of the code. Instead, some recommendations as industry best practice recommendations did get put into another publication that was published last year as a handbook, a practical handbook for implementing CSA B52. And this handbook, not being an adopted code, is not enforceable. Having said that, if any incident happens, basically the actions taken are going to get evaluated based on industry best practice. And therefore, the recommendation of a publication such as this one will become really handy to review. So I really encourage you to go through those recommendations and follow those as well. The second recommendation that's to a CSA Code Committee was recommendation number 15. And we were basically asking Code Committee to reevaluate the intended purpose of the emergency discharge provisions of CSA B52 Annex B and consider eliminating it from the code or discouraging its use. This recommendation, however, did get implemented in the 2018 revision of the code, and that's because there has already been talk within the Code Committee toward elimination of this requirement even before the incident happened. And the incident basically only accelerated that decision to be made. And so it is already implemented in the 2018 revision of the code, and it's tying it to the requirements of or status of the relief piping system. Basically, it's saying that if an existing refrigeration system or a new refrigeration system on the relief piping is compliant with the current requirements of this code, which is 2018 revision, then the emergency discharge line shall not be required. But for those existing systems that the relief piping is not compliant with the current code, then it's asking for the emergency discharge line to be considered. Having said that, the 2018 revision of the code is not yet adopted in BC and therefore is not enforceable in BC. So the fact that 2018 revision is not adopted, and in terms of the secondary coolant recommendations, it did not even end up in the enforceable body of the code, made Technical Safety BC to work on a couple of safety orders in order to mitigate and control the risk. So last year, we formed a technical advisory group with representation from different sectors of refrigeration industry. We had representations from consultant engineers, contractors, training providers, operators, maintenance managers, and owners. And we had really good discussions on the technical requirements of these two safety orders, as well as we did also consulted on these two safety orders internally with all safety officers based on their findings around the hazards. So the first safety order that I'm going to be talking about today and going through the details of its technical requirement is Safety Order SOBP 2021-01 on secondary coolant. As I mentioned, this safety order has already been developed, and we're just performing really final touch-ups before it gets issued this month, by the end of this month almost. This safety order is applicable to all ammonia refrigeration systems utilizing an indirect refrigeration system type. Basically, if you have any type of secondary coolant, either on your low side or high side, and at the same time your main refrigerant is ammonia, then your plant is subject to the requirements of this safety order. On the low side, similar to like any ice rink, the brine piping or glycol piping is considered as a secondary coolant. Or in case of industrial plants, if you do have glycol fan coils within your refrigerated areas, then that is using an indirect system. On the high side, if you do have, say, heat recovery system or a cooling tower, and you do not basically have any evap condenser on the roof, then in that case, the high side does also have secondary coolant, and that portion of the secondary coolant is also subject to the requirements of this safety order. So the safety order does have a couple of distinct parts. First part is on secondary coolant testing, and the second part is on secondary coolant piping system. The first part, which is secondary coolant testing, is basically a replacement for an existing safety order, i.e. SOBP 2017-01. As many of you may already recall, after the incident, Technical Safety BC issued one safety order asking the owners of all public assembly plants, i.e. ice rinks and curling rinks, to perform one brine test for presence of ammonia and submit the results to Technical Safety BC by end of December 2017. It also asked the owners to continue doing the brine test twice a year, but it was not really clear on whether or not those results needed to be submitted to Technical Safety BC or not. So as you can see, this safety order was only applicable to public occupancy types, and also it was mentioning only brine, which is only one of these secondary coolants out there. So in order to fill all those gaps, the plan is to rescind that safety order and replace it with a new one upon issuance of the new safety order. And within the new safety order, we're still asking for 2 secondary coolant testing to be done per year. And the test must be done for all requirements of CSA B52 clause 8.4.2 subclause J, which is basically asking for tests for pH level or flow rate or freeze points or sediment levels. But on top of that, we're also asking for testing for presence of ammonia or change in ammonia level residues, which I'm going to be talking about that shortly. Testing for corrosion inhibitor level, as well as testing for iron content, both in visible and dissolved forms. So the reason that we are also including change in ammonia level residues is that, for example, one type of secondary coolant that can be seen or can be used is ammonium hydroxide, which is basically an ammonia solution. If you don't include that, any test that you do on that ammonium hydroxide secondary coolant is going to come back with some level of ammonia in it. But that level of ammonia should be of a known concentration. And what we're asking you to do is to keep an eye for, if you do see a rise or jump on that ammonia level, that means that the excess amount of ammonia must have come from a leak within your heat exchanger. Also, if you have experienced any leak in the past, even though that you might have already taken care of the leak and replaced the heat exchanger, and even perhaps replacing the entire secondary coolant charge and flushing the floor and piping, you may still see some traces of ammonia within your new charge. So anytime that you do a test, it might still come back with some level of ammonia in it. But those levels of ammonia should be really minimum and should be consistent among between all of your tests. What we're asking you to do is to keep an eye for a jump on that ammonia level, which could be an indication for a new leak happening on your heat exchanger. So the test, the safety order is also asking for some standards on the testing method for ammonia presence. We have basically put in the safety order that what methods are acceptable: ASTM 1426, EPA 350.3, and SM 4500-NH3. So one thing to keep in mind is whenever you're sending your samples to a lab for testing, please ask the testing laboratory to do put on the report which one of these methods they have used in order to detect ammonia in their system. Also, with this safety order, we're no longer asking you to submit your test results to Technical Safety BC. Instead, we're asking you to maintain the records of all of the tests for a minimum of 7 years, and they shall be available to Technical Safety BC upon request by either safety officers, or if in case any incident happens during the investigation, we might ask for the history and tests that were done on the secondary coolants. One thing that is common between the new and existing safety order is we're still asking you to take immediate action toward any ammonia found in your secondary coolant, and do not delay it to either the end of season or in future to deal with that ammonia leak into the secondary coolant. As well as we're still asking you to report any ammonia presence found in your secondary coolant to Technical Safety BC as an incident. The incident reporting instruction is actually detailed in an information bulletin, IBBP 2017-01. Basically, it's asking to report them back to us either through the client portal or through Technical Safety BC website, or you can just simply give us a call at that 1866 number and report the incident. So the new part that basically is new to the safety order is second part of the safety order on secondary coolant piping systems. As I mentioned, this part is new and did not exist in the old safety order, i.e. the BP 2017-01. And this part is also applicable to all occupancy types, and also it covers all different types of secondary coolants, whether it is brine, glycol solutions, ethylene or propylene glycol, ammonium hydroxide, or etc. Or even chilled water, for that matter, could be considered as secondary coolant. And as long as your main refrigerant is in fact ammonia, then your plant is subject to the requirement of this part of the safety order as well. Rather than being prescriptive, we basically decided to be descriptive and describing the hazard here, which is basically overpressurization in the secondary coolant piping in the event of an ammonia leak system. So what we're asking you to do is to provide provisions to prevent that risk. But we're not just leaving you on your own to come up with any solution, and we're not leaving you alone. We are providing you with a few options that, following at least one of the following options that I'm going to be describing about, is going to address the risk here and will make you compliant with the requirements of safety order. So as I mentioned, the regulatory requirement is to only follow or at least follow one of the options, but you're more than welcome to combine as many options as works the best for you in order to move another step forward towards safety. So the first option that you can be compliant with this requirement of the safety order is to add a relief valve to your secondary coolant piping, especially when it can be isolated from an open expansion tank or the remainder of your secondary coolant system. If you choose to go with this option, the valve sizing must be done by a qualified individual, i.e. a professional engineer or a class ref contractor. And at very end, we're going to be asking you to submit the valve sizing documents as well as a photo of the installed pressure relief device to Technical Safety BC as a proof of compliance. Obviously, one thing that you want to keep in mind is the discharge from that valve cannot basically go into the open machinery room, and it should be either piped back to the secondary to the expansion tank or piped into another means of controlling the discharge from this relief valve. Keep in mind that the valve could be popped at the time that ammonia was leaked into the system. So the discharge of this valve could be an ammonia-rich brine. So you don't want to have it splashing into the room. Throughout this, the following few slides, I'm going to be talking about proof of compliances, and just keep an eye for those proof of compliances. I will be talking down the road through this presentation on the means of submitting those proof of compliances back to Technical Safety BC. The second option to become compliant with this part of the safety order is by providing some sort of a means of on the isolation devices that it always exposes the secondary coolant piping to an open expansion tank. So if you do have any isolation valves, you want to actually leave them on open position all the time and put a lock on them. But as those valves are there for a reason, especially for whenever you are actually performing some maintenance, we would like to also, we're asking you to also develop a safe operating procedure for the times that those valves do need to be operated. Those SOPs and safe operating procedures must be developed by a qualified individual, i.e. either professional engineers, class ref contractors, or if you have the expertise and capabilities in-house, it can be done in-house by an individual who has either refrigeration operators certificate or a power engineer of 4th class or higher. And at very end, obviously, we're going to be asking for that safe operating procedure to be submitted to Technical Safety BC as a proof of compliance. I'm just going to go through what that SOP should look like in terms of the SOP to be functional. So the SOP should be site specific. It should address the exact equipment in your site and not a copycat from another plant. You can definitely get help from the other plants, but at the end of the day, you want to make it site specific and specific to your own equipment. It should also have provisions for locking the valve to always expose the system to an open expansion tank. It should have provisions for valve lockout operation to be done by authorized personnel only. You don't want anyone to go out there and remove the lock and operate the valve. It should have provisions to mitigate overpressurization risk if the system is to be isolated, i.e. like, for example, what happened at Fernie, the ammonia was still left within the room after it got isolated, which did complicate the situation even further. So your SOP should have provisions for those kind of situations. Any safe operating procedure is only as good as how good it gets implemented, and that cannot be done other than by providing training. So your SOP should have provisions for staff training on this SOP. And similar to any other procedure, it should have provisions for periodic review of the SOP in order to either improve it or make any necessary changes and updates. Obviously, if such changes and improvements happen to your SOP, you want to train your staff again on the new revision. So the third option in order to become compliant with the secondary coolant piping system portion of the safety order is to develop an inspection plan to evaluate the system integrity. Basically, as you may recall, the main hazard was overpressurization in the event of an ammonia leak into the secondary coolant. So if you can predict properly that the leak is not going to happen in the foreseeable future, for that period of time, you are mitigating the risk. For that one, we're asking for the inspection plan to also be developed by a qualified individual. In this case, it has to be done by a professional engineer or a class ref contractor. And at the end of the day, we're asking you to submit that inspection plan to Technical Safety BC as a proof of compliance. But what such plan should include, we're asking for the inspection plan to include, should have provisions for defined periodic inspection of the pressure boundaries that come in contact with the secondary coolant, i.e., for example, in case of a shell and tube chiller, it will be the tubes that are in contact with the secondary coolant. Don't forget that you are inspecting the regulated item, which is the chiller, but when it comes in contact with the secondary coolant, it's basically the tubes. So it should have provisions for periodic inspection of those part of the system. It should also have provisions for qualified organizations who can perform this type of inspection. It should have provisions for the inspection results to be reviewed by a professional engineer and signed and sealed by him or her for fitness for service evaluation. So your professional engineer will be reviewing the results of the inspection and evaluating whether or not the equipment is fit for to be put back into the service. It should have provisions for periodic review of the inspection plan for any necessary changes. This is not only specific to this plan or procedure. Any procedure needs to be reviewed periodically for any improvement or changes. And it should have, it should also have provisions for action items to be taken when the system is not fit for service. So if your professional engineer comes back letting you know that the system is no longer fit for service, either to the wall thickness being too thin or maybe even too much corrosion happening, then your inspection plan should already have provisions for the actions to be taken following that kind of evaluation, either removing the equipment from the system immediately or replacing it immediately, or whatever provision that you would like to include within your inspection plan. Fourth option to become compliant with the requirements of secondary coolant piping system is to let the leak happen and accept that the pressure is going to rise within your piping system. But then you're considering that portion of the brine piping system as pressure piping. And therefore, we're asking you that if you choose to go with that kind of option, you then need to, like I said, consider that pressure, that piping as pressure piping. It needs to then be designed as per the requirements of ASME B31.5. And because it is a pressure piping, i.e. a regulated item at this point, all of the administrative and technical requirements of pressure piping is applicable here too. So the design must be done by a qualified individual, i.e. either a professional engineer or a class ref contractor. If you do have any piping larger than NPS 3 in size, the design needs to be registered. We're talking about the pressure piping, so it must be only installed by a class ref contractor. And Upon completion of that work, we're asking for a pressure piping construction data report to be completed. At the very end, we're asking for a submittal of the design registration letter that you will receive back from Technical Safety BC, as well as the construction data report as the proof of compliance. So these are the 4 options that we came up with, but we're not eliminating any other options that could be out there. If you as the owners do have any alternative method to address the risk, you are more than welcome to implement that method as well. As long as you share that method with us ahead of time by submitting it to BPBR support at Technical Safety BC, we're going to be reviewing that alternative method to make sure that it is in fact addressing the risk of overpressurization within secondary coolant in the event of ammonia leak. And then based on your proposed alternative method, we will then identify some proof of compliance documents. Basically, at very end, we're asking you to submit those list of proof of compliance documents, as well as the acceptance email that you will receive from the boiler senior safety officer on your alternative method. Okay, so in this half of the presentation, we're going to go over the second safety order being issued this month. So safety order SOBP 2021-02 on emergency discharge line. This safety order was also developed through the same process by both internal and external consultation with either our safety officers or that technical advisory group that I talked about. It's also in its final format, and we're just performing some final touch-ups before we can issue them by the end of this month. This safety order is applicable to all ammonia refrigeration systems in all occupancy type, regardless of what type of system they have, whether it is direct, indirect, volatile, or like any different type of refrigeration system that has ammonia as its main refrigerant, then is subject to the requirements of this safety order. One question that could pop up here is like, I know that there are some cascade type CO2 refrigeration system that on high side, they do have another refrigeration cycle or refrigeration system. If that high side is also using ammonia refrigeration system, then that part is also subject to the requirements of this safety order. So just to keep the rules simple, if you have ammonia refrigeration in your plant, then your plant is subject to the requirement of this safety order. It also has provisions for both new installations as well as existing plants and existing installations. For new installations, it's fairly straightforward. As a new installation, your plant must be compliant with all new requirements of the codes, i.e. Including the pressure relief piping. So in this case, your new installation's pressure relief device is going to be compliant with the new the requirements of CSAB 52. And as a result, we're asking you to eliminate the emergency discharge line from your design and ultimately from your installation. So you're installing a new ammonia refrigeration system, you do not need to have an emergency discharge line, or otherwise known in the industry as fire line. How we're going to be looking or keeping a record of compliance for the new installations is that all new refrigeration systems do require a system design registration. And this is actually something other than the piping, pressure piping design registration. So as long as it is a refrigeration system and it's not a CSA approved self-contained unit, then that system does require a system design registration. And at the time of review of that system design by our engineering team, then the requirement of this portion of the safety order for new installation is going to get reviewed. Basically, that is going to provide you with some saving. The requirement is no longer needing you to, asking you to install a fire line or emergency discharge line. For existing Installations, however, it's rather more difficult. You need to go back to your own pressure relief piping system to see if it is compliant to the requirements of the new code or not. The significant change on the requirements of around relief piping was actually happened back in 2005 within CSAB 52, the 2005 revision. So if your relief system is designed and constructed as per the requirements of CSAB 52 2005 or any newer edition, then that means that your system is compliant with the requirements of the new code. If it is compliant to B52 2005 and newer, then you are also compliant to the requirements of the current code. And if it's compliant to either 1999 or older revisions, then you're not compliant to the new code. So then based on that, the compliance of your relief piping system, if your system is already compliant with the new requirements on relief piping system, then you have a couple of options. First option is to permanently disconnect the emergency discharge line from your system. In this case, the work needs to be done by a class ref contractor. And what we're going to be asking you to provide us as a proof of compliance at the end is a photo of the disconnected nozzle on your pressure vessel, which is now capped. You don't really have to physically remove the entire dead pipe at this moment from your plants. It's highly recommended to do that in order not to cause confusion in future. However, as for regulatory requirements, at this point, disconnecting it and capping it at the pressure vessel's end will be satisfactory. So the second option is that if you decide to keep the emergency discharge line in place and do not want to go through the disconnection of that emergency discharge line, by all means you can do that as long as you develop a procedure for the operation of that emergency discharge line valve. So what you need to include, I'm going to be talking about the requirements of such procedure down the road, like in a few slides, but keep in mind that that procedure needs to be submitted to Technical Safety BC at very end as a proof of compliance. For the existing plants that their relief piping system is in fact only compliant to the code of construction at the time of construction, i.e., and it's actually only compliant to the CSAB 52 1999 or earlier, they also have a couple of options. First option is to upgrade their relief piping system, their entire relief piping system to the new requirements and disconnect that emergency discharge line or fire line. If you choose to go with that option, then that upgrade needs to be designed and sized by either a professional engineer or a class ref contractor. The work has to be done by a class ref contractor. Relief piping system, basically at very end, we're asking you to submit all of these sizing documents as for the relief piping system, as well as the photo of disconnected emergency discharge line at the pressure vessel end, and which is now capped. So those are going to be the proof of compliance that you're going to be submitting to us if you choose to go with this option. The other option is to keep your relief piping system only compliant to the code of construction at the time of construction, at the original code of construction. And therefore, now you need to also keep the emergency discharge line. In this case, also, you need to develop that safe operating procedure for the emergency discharge line valve. And we're going to be asking you to submit that safe operating procedure to Technical Safety BC as a proof of compliance. But what that safe operating procedure should look like, you can actually seek out for help from your professional engineers, licensed contractor, and also consult it with the first responders whenever you're developing such procedure. But keep in mind that your procedure shall actually include the following requirements. Obviously, it must be site specific. You can definitely get help from the other plants, but at the end of the day, you want to make sure that it is specific to your own plants. It must have provisions for circumstances at which point the emergency discharge line valve is allowed to be operated. Basically, performing that cost versus benefit analysis ahead of time, going through different scenarios, and providing with clear instruction that in case of an emergency, whether or not the valve should be operated or not. It must have provisions for person or persons authorized to operate the valve. And when such person is not available on site during an emergency, have provisions for delegating such authority to others. This authority is most of the time going to be only given to either the chief engineer or the person in charge of the plant, but it's up to you. At the end of the day, that person has to be authorized to, has to be certified to operate a refrigeration system. And also, whenever he or she is not available on site in case of an emergency, we're asking for this safe operating procedure to have provisions on the means of delegating that kind of authority, either by direct instruction over the phone, or maybe a delegation is already included within the safe operating procedure. It must also have provisions for safeguarding the emergency discharge line valve box and providing access to that valve box only to authorized personnel in this case. So as you may recall, the valve box currently is asked to be glass fronted so that it can be broken in case of an emergency. What we're asking for here is that in order to prevent it from operation by unauthorized individual, we're asking to add some locks and make sure that it cannot be accessed by anyone else other than the authorized personnel. Obviously, the lock to that safeguarded valve box should be available to anyone who is authorized by your procedure to operate the valve. It should also have provisions for contamination control after the emergency discharge line valve is operated. You need to have provisions within your safe operating procedures on evaluating the wind direction and neighborhood, whether or not it is residential or industrial, notifying the neighborhoods of such release, making sure that they do have enough time to either evacuate, and also provisions for notifying the first responders and making decision on the contamination control of the neighborhood. It must also have provisions for training of those personnel who are authorized to operate emergency discharge line. Again, this is not only specific to this procedure. Any procedure must be, staff must be trained for that procedure in order to implement it properly and as per the requirements of that procedure. It must also have provisions for record keeping of such training, must have provisions for periodic review of the procedure and make any necessary changes or updates. Obviously, following such updates or changes, staff needs to be retrained on that procedure. The procedure should be also shared with the first responders, such as fire department, so that they know that there are some procedures in place for operation of that valve in case of emergency. And the procedure must be easily accessible to those who are authorized to operate it. In many cases, now that your valve box is in fact safeguarded and locked, you might want to even have a copy of the procedure available within the valve box. So these are basically the technical requirements of the two safety orders that we talked about. Even though there are multiple options provided in either one of these safety orders. As long as you are compliant with at least one of those options, then you've satisfied the regulatory requirements. But like I mentioned before, you're more than welcome to combine any of those options in order to move another step forward towards safety. So now we're going to go through the administrative requirements that you need to follow in order to become considered as a compliance duty holder. So the safety orders are planned to be issued by the end of this month, March 30th, at which point we're planning on sending emails or physical letters to those plans that we have records of them in our database, notifying them that their plan has been impacted by at least one of these safety orders. Having said that, like I said, if your plant is an ammonia refrigeration system and you did not receive such notification, you're still required to comply with the requirements of these two safety orders. The safety order on that day, on March 30th, is going to be posted on our website. So what you can do is that you can actually go to Technical Safety BC website and then take a look at the BPVR symbol, click on that. Then on that one, you can actually look at the view regulation, click on that one. It is going to lead you to the page that has all of the safety orders, directives or regulations and info bulletin. Over there in the area that talks about safety orders, you will find the two new safety orders. There are a couple of due dates, which is consistent between the two safety orders within them. First due date is on June 30th of 2021, which is for compliance method declaration. And the second one is February 28th of next year, 2022, which is going to be the compliance declaration. By June 30th of this year, all impacted owners are required to declare what method they're going to be using in order to become compliant. And the way that you can communicate that method declaration back to us is that there are a couple of forms available on our websites, which you will be provided with a link to those codes after the safety orders are issued. Form 1734 is the compliance method declaration for secondary coolant, and 1736 is compliance method declaration for emergency discharge line. You will then need to submit them or email them to BPVR support at Technical Safety BC. The means of submittal of those forms cannot be done through client portal. You need to submit them to this email address. Do not submit them through the client portal. Just going to go through an overview of those forms. 1734, compliance method declaration for secondary coolants. This form, section A of that form, is basically asking you for some generic question about your plant. So such as like owner's name, contact information, mailing address, and phone number. On section part, we're going to be asking you to provide us with information about your site and your equipment, site address if it is different from the permit holder, name, person in charge of the plant, his or her certification, and email address. We're also asking you to provide us with what kind of occupancy your plant is installed in, operating permit number, and also unit number. And we're asking you for the total prime mover or compressor nameplate rating in terms of kilowatt or horsepower, as well as total ammonia charge in kilograms or pounds, whichever way that's you're reporting it to us. Then section C of this form is the declaration part. Within this section, you're going to be providing information on whether or not that secondary coolant is on your low side or high side. On low side is basically on evaporators, chillers, and on high side, if it is on your water-cooled or glycol-cooled condenser, de-superheater, or those type of equipment. The type of secondary coolant that you're using, whether it is brine, glycol, or ammonium hydroxide, or etc., or chilled water. Secondary coolant system, is it open or closed? And then declaring that which one of these options you're going to be implementing in order to become compliant. You can select as many options as you want if you are planning to be compliant with more than one, but at least minimum one of them needs to be selected, providing the information that we're asking you here as well. We are providing three parts for secondary coolant. We're providing three sections as C1, C2, and C3, if in case you have more than one secondary coolant piping in your system, i.e. if you have both low side and high side. I know that like many of the low charge ammonia systems, on the high side, they do have cooling towers, or like maybe they are going with heat recovery, so they do have another secondary coolants on the high side. And obviously, second D is where you sign it and send it back to us, emailing it to technical safety BPVR supports at technicalsafetybc.ca. As for Form 1736 for compliance method declaration for emergency discharge line, again, Part A is asking a question about the permit holder information. Site B is also asking questions about the site itself. Similar to the secondary coolant part. The other type of information that we're asking you to provide us here with is original year of construction, as well as last major retrofit on your relief piping system. And as you can imagine, we just want to gather information on whether or not your system is compliant with the new requirements or not. Part C of the form is asking you to declare whether or not your system is compliant to 2005 or newer, and if it is or is not, what kind of method you're going to be using. Are you going to be disconnecting it, or keeping it in place and developing a safe operating procedure? Or in case of the answer being no, are you going to be upgrading your relief piping system and disconnecting the emergency discharge line, or you're going to be keeping them and developing that safe operating procedure? Part B of this form is also similar to the other form, is signing and sending it to Technical Safety BC as your method, compliance method declaration. Again, you need to send it to BPVR support at technicalsafetybc.ca, not through your client portal or through other means of contact with Technical Safety BC. So for second due date on February 28th of 2022, you need to be fully compliant with the requirements, and you must have already implemented the method that you've selected. And then you need to report that compliance back to us by completing the compliance declaration forms, the two forms of 1735 for secondary coolant and 1737 for emergency discharge line, as well as any of those compliance, proof of compliances that we've been talking about throughout the presentation. Again, the means of declaration is not through the client portal, but through sending it to the email that is provided here. All of these instructions are also spelled out within the safety order itself. Going through those forms as well, Part A and B are exactly the same as the compliance method declaration forms. Part C is also very similar. The only difference is that you're now also declaring that you're attaching the proof of compliances. And it also spells out what proof of compliances we're talking about as a reminder. When you're filling it out, you can actually make sure that you have all of those documents available, and you're attaching it to your email. Part D is also the same. As for the emergency discharge line, it's also the same. So part A and B are identical. Part B is also identical, with the only difference being that it has mentions of the proof of compliance documents. And part D is the part that you're going to be signing it and sending it to Technical Safety BC. So this part is going to be basically saying that, like, what happens if you're not sending that final compliance declaration. If the final compliance declaration form is not sent together with the proof of compliances, basically your plant will be considered as not being compliant with the requirements of safety order, and failure to comply with the requirements of the safety order may result in enforcement actions under the Safety Standard Act and regulations. If you want to get more information on the Technical Safety BC enforcement action and also progressive enforcement, you can actually get on our website, Technical Safety BC, and go on enforcement and get those information. So this basically concludes our webinar on the two safety orders. However, we're also asking you that after this webinar, please take a short survey, it's a few question survey that we're asking you to provide us with your feedback on this webinar itself, as well as your feedback and concerns around the safety orders being issued. And we really appreciate if you could participate on that safety order. So where you can find that, on that survey, and where you can find that survey is through that same means. All of you that are here have already enrolled for this webinar, so you already know where to go. On that same enrollment page, you can actually find the survey available. Please go ahead and complete that survey. It's really appreciated. Next step, basically what we're doing is that we're asking you to stay connected through your client portal. You can actually pull permits, pay for them, or view your current permits through the Learning Center that now all of you must have an account for, and you already know that, like, the account for Learning Center is different than the account for the client portal. You can actually register for all of the either online courses or instructor-led courses. As many of you already know, due to the COVID-19 situation at this time, we do not offer any in-person session, but that does not last forever. And hopefully in future, we're going to be providing some instructor-led courses. There are really good, useful courses, and we do encourage you to take a look at that and enroll for anyone that is applicable to you. And you could also sign up for our newsletter. There will be some really good either regulatory or really good information being provided on those newsletter. So please go ahead and sign up for the for receiving the newsletter from Technical Safety BC. Again, as I mentioned, you must have already signed up for this presentation, and that's why you're here. So you are already familiar with our Learning Management Center, and by scrolling through the courses available on that, you can actually select whichever one you're attracted to and sign up for them. There are a variety of courses available, either like self-paced courses that are online, or there are some instructor-led courses as well. So with regards to these two safety orders, if you have any further information or question, rather than like getting to the client care and asking them the question, which may not have all the technical background to answer your question, we do encourage you to either reach out to your local safety officers or simply just send your inquiries to bpvrsupport@technicalsafetybc.ca, and we're going to get back to you as soon as possible to answer your to reply to your inquiries. Okay, so that concludes our presentation part. We can actually go into the question and answer session. Because of the large number of attendees, which is really good, I'm not sure, I don't think that we're going to be opening it up to floor for questions. If you still have any questions, please keep typing them in the chat box, and we're going to be going through all of the questions that have already been typed in the chat box. I'll give it back to you, Harpreet, for the questions.
Perfect, thank you. Okay, so we will start with some of the top questions that we received earlier in the webinar. Some of these have been answered, but it's not a bad idea to go through them again, just in case we just missed something that maybe not everyone captured. So the first question was, will the safety orders be sent to the facilities, and when are the safety orders going to be available for download?
So as I mentioned, the safety orders are going to be posted on our websites by end of this month. And those facilities are going to receive a notification email with the links to the safety orders. So you're not going to receive any physical letter unless you have not provided us with an email address to communicate with you. They can be downloaded from our websites.
Okay, perfect. Let's see here. Is the overall direction of Technical Safety BC to go away from ammonia?
No, the answer to that question is absolutely no. Ammonia is still the most environmentally friendly refrigerant out there, and we do encourage you to keep ammonia as your main refrigerant. Having said that, it comes with its own risks. As long as you are well aware of those risks and you are managing them properly, it is in fact encouraged to go with ammonia.
Okay, next question we have is, what size of ammonia leak defines an incident?
When it comes to incidents, it's basically uncontrolled or unplanned ammonia release. So if, for example, you are performing any maintenance within your on your equipment, and there are some intentionally you're releasing some ammonia, or you're sniffing some ammonia within the room, then that is not considered as an incident. However, if without having it planned, even during that same service, if without having a plan an ammonia leaks out, that is an indication that something happened. Regardless of the quantity of refrigerant leaked out, it needs to be investigated to see what happened, and is it going to be safe to put it back into the service. So any amount of refrigerant, uncontrolled or unplanned refrigerant leak or ammonia leak into the either room or atmosphere out of the boundary itself is considered as an incident.
All right, perfect. Here's another question. Can you please review how many secondary coolant test results are to be submitted to Technical Safety BC, and are they to be submitted by email or through the website?
So the answer to that one is none. So we're not asking you to submit any secondary coolant test results to Technical Safety BC, but as I mentioned, rather we're asking you to maintain a record of all of those test results for a minimum of 7 years. And I know that there must have been some sort of a confusion through the existing safety order, but you're no longer required to submit them to Technical Safety BC.
Okay, so this one here seems like it's a little bit code related. So B52 18 8.4.2 concludes with the following wording: the tag shall conform to the requirements of environmental regulations. Can you please provide a reference to which regulation this refers to?
So basically, as far as I recall correctly, I don't have the code right in front of me, but as far as I recall correctly, that section of or clause of the CSA B52 is asking for all of the tested and calibrated equipment and inspected equipment to be tagged for the requirements of CSAB 52. And the tag is asking for it to be environmentally friendly. First of all, cannot be like deterred over time. And I can look further into this, but as far as I know and I recall, I think it is referring to the tags to be attached to inspected items or calibrated and tested items.
Okay, perfect. There's another couple more questions here. Is elimination of the fire line dependent on the quantity of refrigerant in the system?
No, not anymore. So what we're saying is that it's totally dependent on the design of your relief piping system. If your relief piping system is compliant with the new code, 2005 and your version of the CSAB 52, then you can eliminate it. If it is not compliant with that code, then you need to keep it in place. Historically, those fire lines or emergency discharge lines were put in place as a manual relief. They used to install ammonia refrigeration in the basement of the system. And back then, because the relief piping was not, requirements was not developed properly, in case of any fire, they would have actually gone through overpressurization and could even have some explosions. So this emergency discharge line was introduced into the code in order to address that risk by means of providing some sort of a manual relief for the fire departments that can manually release the ammonia and actually relieving the pressure. So now if your relief piping system is in fact compliant to the new requirements, which has all of those considerations into account, then you no longer need the emergency discharge line or fire line. And in fact, having that one is, it is redundant, and then having that one could impose another risk of like, because it could be prone to mistakenly open, similar to what happened at Fernie.
Okay, perfect. So moving along. So is locking the brain expansion tank isolation valve open acceptable unless servicing the tank is needed to create an SOP?
Absolutely, you can actually lock it open. In fact, that is, if you are going with that option, you have to lock that valve open so that the brine piping is always exposed to that expansion tank. But as you mentioned, there could be some occasions that you need to close that valve. So the purpose of that safe operating procedure is to provide you with means of how to safely close that valve without complicating the risk and hazard.
All right, perfect. Let's see here. Okay, so here's some questions after the submission for a compliance method. What happens if we want to change our mind after we submit the compliance method declaration?
Sorry, could you repeat that again?
Sure. What happens if we decide to change, if we change our minds after we submit the compliance method declaration form?
You're more than welcome to change your mind. So after you submit your compliance method declaration, if you reevaluate your the options available and find another option fitting your organization and your facility better, you're more than welcome to do that, as long as you do have enough time to implement it. So what we're asking you to do is that by February 28th of 2022, you need to at least implement one of the options and report that implemented option back to Technical Safety BC. The main purpose of the first declaration form is for us to know what kind of mix we're going to be seeing in terms of compliance method, as well as it is going to be providing you with an opportunity to plan ahead and allocate time and budget for those options that are available to you, and not leaving it for the 11th hour, basically.
All right, perfect. So there was another clarification question here. So just to clarify, did you say that we no longer have to submit our brine samples through the website, we only have to keep them on the premise for 7 years?
That is correct. So you need to keep all of them on the premise for a minimum of 7 years. And if the result comes back with presence of ammonia, you need to immediately report it to Technical Safety BC as an incident report. You don't need to submit it to Technical Safety BC through the portal, but you need to submit to report it as an incident.
All right, perfect. Couple more questions that are just coming in through the chat box now. If you want the emergency fire line removed, where would you like the ammonia vented in case of a fire?
So in case of a fire, the situation was the relief valve designs and sizing in the older revisions of the code was not adequately considering all of the fire situation into the factor. Those who are familiar with the sizing know that like there is a factor, F factor, that is multiplied by the size of the pressure vessel in order to come up with the requirements, the CFM requirement, or sorry, pounds per minute of the air requirements of the relief valve. That factor, if you go back through the history, has actually gone through a lot of changes. For example, for ammonia, it used to be 0.1 back in the day. And now more research has gone into the sizing in terms of the impact of fire on how rapidly it can actually alleviate the situation and raise the pressure within the tank, and what kind of impact that is going to have into the size of the relief valve. As well as the new requirements are considering the effect of back pressure on the relief valve. So it's quite significantly got changed, and thorough research has been done on that. So in case of the fire, your pressure relief valves are going to be taking care of the overpressurization system. And now your pressure relief valves are actually vented through the relief stack in the proper location, which is spelled out within CSA B52.
Okay, perfect. Do reliefs installed on secondary refrigerant piping systems have to carry a certification such as ASME UV?
As long as, so again, if you are not considering the secondary coolant as pressure piping, but you are in fact moving towards installing a pressure relief valve, we are asking you for that relief valve to be certified, or at least have some sort of a certification in terms of providing with some assurance that it will do what it's supposed to do. So certification is required for that valve, that relief valve.
All right, perfect. So just a couple of questions have been coming in the chat, so we'll do our best to get through them. If we remove ammonia from the system, does this eliminate the need to do monthly bump tests for seasonal facilities?
I assume you're talking about monthly bump tests on the ammonia detection system. That bump test is a requirement of WorkSafe BC. You can actually reach out to them for that to see if that is even allowed. So I would refrain from answering any question that has to do with WorkSafe BC. But
Okay.
if the question, I have actually been approached by a different similar type of question with regards to the safety orders. So if you do have a seasonal operation and your plant is only working for say 6 months a year, the question was whether or not we still need to perform 2 brine tests per year. And the answer is yes, because even after your compressor, you're no longer making ice. As long as your plant, your ammonia refrigeration system is still charged with ammonia, you will still have that risk of ammonia leaking into the secondary coolant. So that is why you still need to satisfy that requirement and perform 2 tests a year. Unless you completely remove the entire ammonia from your system and leaving it in, say, high pressure receiver that has nothing to do with the brine piping. If you totally evacuate ammonia from your chiller or your water-cooled or glycol-cooled condenser and putting it in your high-pressure receiver, then that risk is no longer available.
Okay, perfect. And then this reflects the last question that we received here in the chat box. And once again, if the questions that were communicated were not responded to, just feel free to send over the email as well. We'll be able to answer them there. But this looks like the last one. Would you expect further clarification in the near future requiring updates or further clarifying requirements of ammonia plant emergency exhaust system, either to CSA B52 or the IIAR recommended ventilation rates?
So if I understood the question correctly, is whether or not like those kind of requirements may end up in the CSA code or IAR code. If that is the question, I'm not 100% sure. I know that code committees, at least in CSA B52, are looking further into the requirements of secondary coolant part, but are not talking actively about the emergency discharge line. But I can definitely look further into that. If you could, whoever asked that question, if you could just send that same inquiry to BPVR support at technicalsafetybc.ca. I would look further into that and get back to you with further and detailed answer. One other thing that I would like to let you all know is that this entire presentation has been recorded. I assume it has been recorded. Harpreet, please correct me if I'm wrong. And what we're going to be doing is that we're going to be posting it online for your future reference. So it will include all of the question and answer parts. If you would like to refer back to them, you can actually do that in future as well.
Yeah, it looks like there hasn't been any more questions coming in. I did put the email there that was mentioned. So if any other questions were missed or if they are still coming in, it's bpvrsupport@technicalsafetybc.ca for any questions that may have been missed. Yes, we will be looking at the recording. It did get recorded. Minus the little glitch that we had there with the Zoom, but it should be easy to edit out and get the full recording online. And if you do have any questions, once again, bpvrsupport@technicalsafetybc.ca.